All right, hello, welcome. In this video, we're going to work with some two-variable equations today. Two-variable linear equations. Okay, so this is going to be the second lesson in the first unit of Algebra 2. Okay, so first I need to remind you about the xy plane. And I know you already have heard about this, but I'm just going to remind you about it just to, so we're all using the same language. So last lesson, we worked with some inequalities that had solutions that were intervals along the number line. Okay, so much like that, we're going to have a number line right here. This is what we would call the x-axis. We were mainly using x to denote the real numbers on the real number line last time, so it wouldn't be surprising that we would call that the x-axis. But now we're going to bring in another number line, and we're going to lay it in perpendicular to the x-axis, and we're going to call it the y-axis. And we're going to be interested in, plotting some curves and stuff in this class, and so we just got to start here with plotting points. Okay. So the first order of business, we got to plot the point x equals -1 and y equals 2. Okay, when we see that the coordinate pair like that, that's what it means. Is over here the point where x equals -1 and y equals 2. Okay, so we're going to have to decide where -1 is, and it can be anywhere we want, right? And we don't have a grid. This is our xy plane. We can decide where -1 and 2 are. Make them wherever we want. So we're going to go up here. I'm going to say that's about 2. And then I'm going to plot in green the point -1 and 2. Okay, and it's going to be up here. And that's great. You know how to do that. Okay? Remember, x is first and then y is second. Okay? And remember that up here above the x-axis, that's where y is positive. And down here below the x-axis, that's where y is negative. Okay. Oh, oops. All right, now we're going to plot all of the points where y is equal to x. And what I want you to see here is that when we plot all of the points that satisfy an equation, we're going to get a line. Or later on in this class, we're going to get a curve. Okay. So I think the first order of business is, well, if we want y equal to x, we probably want the point 2, 2, right? Because 2 is equal to 2. So I'm going to go over here about an equivalent distance to the right that I went up on the y-axis. And I'm just going to plot a point over here. Okay, if y equals x, okay, the point 1, 1 would be on there, but the point 1.5 and 1.5 would also be, and there's going to be a lot of points. Okay, point 0, 0 would be on there. I might even put over here, maybe this is -1. And maybe we say that point's here. And then we're going to think about, okay, there's lots of points that satisfy that, including this point, 0, 0, which we would call the origin. Remember that. And then it's going to be, in the end, a whole line's worth of points. Okay, so that's the set of all points where y is equal to x. Okay. Now we're going to, graph a couple of other functions. Now at this point in the course, we're going to start talking about f of x. Okay? And right now, today, all I need you to know about f of x is that it's kind of like a fancy word that means just y, right? Or a fancy concept. Okay? Now later on, we'll talk about the nature of functions in this class, and that'll be some of the really good mathematics we get to talk about. But for now, I think I just need you, when you see f of x, I need you to know that that represents y. So when they say, okay, f of x equals 2x, really we're graphing the set of points x and y where y is equal to 2x. Okay. Now, I'm going to tell you just, a little fact, and that's if we have an equation that's relating the first power of y to the first power of x, that's going to be a line. Okay, so we are expecting a line when we look at the equation y equals 2x. Okay, what you learned in geometry class is that if you have 2 points, you have entirely determined the line that connects those 2 points. Okay, so what I need is 2 points on this graph of y equals 2x. I'll connect them, and then I'll have a good drawing. Okay, and definitely a really suitable sketch. So what I'm going to do is I'm going to go over here, and I'm going to think of a couple of pretty easy ones, right? You could put x and y. Sometimes I like to put x in the formula for y so that I'm just reminded that, okay, I'm going to be choosing x equals 0, and 2 times x, well, that'll be 2 times 0, which is also 0. And then I could do maybe 1 And 2 times 1, well, that's going to be 2. And that will be enough so that we can plot 2 points, connect the dots, and have ourselves a line. Okay, so I'm going to go over here, and maybe that's 1. And I need to go a little bit farther up, right? Probably twice as far. And that'll be 2. And so I will plot the point up here. Try to go down the same way down here. But remember, this is just a sketch. If I need a super accurate graph, I'm going to pull out a graphing calculator. I'm going to bring up my browser window and go to Desmos.com. There are lots of ways I can get super accurate graphs, and by hand is not one of them. So we're going to settle with just a sketch oftentimes in this class. But we don't have to have an explicit equation in order to plot a graph, right? We can have a few points and we can kind of interpret what's happening with this function just based on the points we've got. And so hopefully this is something that you kind of recognize. Maybe this is going to be -2, and I'll try to go out a similar distance there. And then we're going to go up here to 4. Okay, so -2, 4, and 2, 4. Okay. -1, 1, and +1, 1. So we're going to plot these as well. And then the point 0, 0 is also on the graph. This is the graph of y equals x squared, right? Or f of x equals x squared. And hopefully you saw a little bit about this in a previous algebra class or something. But if not, we got plenty of time to study this guy. And that's going to come in a couple of months, right? We're going to really stick to lines and linear situations for quite a while in this class to make sure that we're confident before we move on to higher degrees. Okay, but we will talk about this whole situation, x squared, at great length in this class. So let's move on. And let's talk about those lines, which is why we're here in the first place today. So we're here to graph some lines. 2 variable equations that are linear. Okay, so I need to kind of show you the different versions of an equation for a line, right? The 3 most common forms that you need to know for this class. Okay, so first we're going to talk about slope-intercept form, and that's the one that you probably remember from Algebra 1. That's y equals mx plus b, where m represents the slope, which we have not defined yet, but you can see we're about to define down below. And b is the y-intercept, which is another thing that we're going to define down below. Okay, almost fit it in there. There we go. Okay, point-slope form. Okay, this is if we know a point that's on the graph and we know what trajectory it goes from there, right? Because if I know that it contains this point that I've drawn in blue on the right side of the screen, and it goes kind of to the right, but pretty flat. Okay, well, really, I've got a whole line's worth of points, right? I can go forwards and I can go backwards along the same line. So if I have an initial point and a trajectory, that is going to determine the line uniquely. So I'm going to get rid of all of that, and I'm going to say the form is y minus y0 equals m, which is still the slope, multiplied by x minus x0. Okay, so this is still the slope. We're going to use the same letter to represent slope. But we're going to say that the point x0 and y0 is on the graph of the line. We know that for a fact. Okay. And then standard form is probably the one that annoyed you in Algebra 1. And who knows, it might annoy you in this class as well, but I'll at least tell you what it's good for. It's really good for determining the x and y intercept. Okay, it's not good for determining the slope. You would need to do some algebra and figure that out. It's not the best for a variety of things, but it's really good for finding intercepts. So we'll just put that in, and it's ax plus by equals c. Now, I think usually, provided that it's possible, we try to write a as a positive integer and b as an integer if at all possible. But I know that for some lines that's not going to be possible. And so really, we're just looking at that. Usually standard form is something you're given, and then you have to work with it to get it back to something you're more. But I will put in my advice over here to the side, which is that ax plus by equals c is really useful for finding the x-intercept and the y-intercept, okay? And now I think we need to define what all of these things are, okay? The slope of a line is how steep it is, okay? So I'm going to just give you a couple of examples. I'm going to just, some lines that are going through the origin. How about that? So maybe I'll graph them in pink. So a flat line, that's not going through the origin, but a flat line, that has slope of 0, horizontal. Okay, we'll talk about that more next time. Okay, a vertical line, we're not going to talk about that until next time. I don't even want to get into that right now. But a line that's close to horizontal is going to have a very low slope. Okay, the slope is how much do we expect y to increase by when we increase x by 1. That's really what the definition of slope is. For us in our class, we're going to define slope in terms of its formula. Okay, so this would be a kind of a small but positive slope, because if we're looking at as x increases, what's happening to y? If x increasing causes y to increase, well, then we're having a positive slope, right? If we're going to the right and then up, that's positive. But if we were going to the right and then y was decreasing like that, that would be a negative slope. That, again, pretty shallow, going to be pretty close to 0. But then when we go and we have like a steeper slope, that's going to be a larger slope. Like that might be a slope of 2 or 3 or 4, something bigger than 1. Okay, and then, let's see, then a slope that would be very negative, that could be maybe like -5 or something, right? It's a steep downward slope, and so that would be more negative. Okay, so let's get rid of all this and actually define slope in terms of rise over run, right? You remember that from Algebra 1, the slope is how much the line rose divided by how much it ran. But really, rise and run, those are just different, changing in x and changing in y, right? So rise is how much did we go up by? So it's going to be how much did y change, because y is how high up we are. So it's going to be y2 minus y1. How did y change with respect to, no, not 1, pardon me, x2 minus x1. And this is rise over run. Okay. Then the y-intercept of a line is the point where it hits the y-axis, right? And so that's going to be the place where x equals 0. So I'm going to just draw you a little picture here. Okay, the y-intercept is right here. And think about what the x-coordinate is there. Well, it would be right here, where x is equal to 0. It's right in the middle. So that's why I say that the y-intercept is the point where x equals 0. It's very easy to get this backwards and think, oh, y-intercept, y equals 0. It's not going to be it. Okay? The x-intercept of a line is the point where y equals 0. So maybe I'll draw you a picture of that as well. There we go. Okay, there we have it. Okay, so x is not 0, but if we think about the y-coordinate of that point, it's going to be 0. Okay, so these are the definitions of these things. Let's do an example real quick. Okay, so we're going to start with this line L, which is the line that's defined by being the line that passes through -1, 1 and 3, 2. So we're going to start with a sketch, just to remind you of why 2 points do uniquely define a line. Okay, so maybe -1, 1 is about here. And 3, 2 is going to be up here. Okay. Now, you're not going to be able to see me do this, I guess, unless I show you. Left it over there. But I've got this handy straight edge that was given to me one of my favorite students, and I'm going to lay it down on what I'm drawing on, and use that to help me draw a nice line. If you think about it, there's only one line that can pass through both of these points, right? If it was a different line, it would not be able to pass through both of them. Okay, so that's my sketch. Right? I didn't even. Probably should label my axes, and I probably should label my points too, but it's just a sketch. It's not a huge deal. It's got a positive slope and a positive y-intercept, and the slope isn't very steep, so that's what we need. Okay, so in order to compute the slope, I'm going to go over here and I'm going to label, just to be as explicit as possible for y'all, I'm going to label what's x1 and x2 and what's y1 and y2, right? Well, -1 and 1, that's a point. That's an x value and a y value. So this is x1 and y1. And then 3 and 2, this is x2 and y2. Okay. So the slope we know is equal to y2 minus y1 divided by x2 minus x1. Okay. Which is going to be 2 minus 1 over 3 minus -1. Okay, so that's going to be 1 divided by 4. Okay, so I've got a slope. And now I've got 2 points to choose from. And so I've got a slope, I've got some points, I want to use point slope form. Definitely, no doubt about it, use point slope. So what we're going to do is we're going to say, all right, we know that the point slope version of the equation for a line is y minus the y coordinate of the point we know is on the line is equal to the slope, which we just computed as 1/4, and so I'll plug that in a second. The slope times x minus the x coordinate of the point we know is on the line. Okay, so it doesn't matter if you choose -1, 1 or 3, 2. In fact, I'm going to show you that it's going to work out the same either way. I'll just choose 3, 2 because they're both positive, right? So I'm going to say y minus 2, because that's the y coordinate of the point I'm choosing, using 3, 2, is equal to the slope times x minus the x coordinate of the point we know is on the line. Okay. Now, I'm going to also say that we could have used y minus 1 equals 1/4 of x minus -1. Okay. And I'm going to show you that these are equivalent, they represent the same line, by kind of working out the algebra and putting them both into slope-intercept form, because that's another thing you're going to be expected to do in this class. Okay, so if we got to go from point slope to slope-intercept, say to find the y-intercept or something, we're going to distribute that 1/4. So that would be my y minus 2 equals 1/4 of x minus 3/4. Okay. And then we're going to add 2 to both sides. Now, if I'm adding 2 over there to -3/4, well, that's going to be 8/4, and I'm going to subtract 3/4, and I'll be left with 5/4. Okay. So adding 2 to both sides, 2 minus 3/4, that's 5/4. Okay. And then over here, we're going to do the same thing. We're going to distribute. And so I'll have y minus 1 is 1/4 of x plus 1/4 of 1. Okay. And then I'm going to add 1 to both sides, right, to solve for y. Didn't really leave myself enough room to show a whole lot of work, but when I add 1 to both sides, it's like adding 4/4. So it would be 4/4 plus 1/4 is going to be 5/4. So y is going to equal 1/4 x plus 5/4, which I already knew, but that's what I was setting out to show you, is that you're going to get the same thing regardless of which point you choose. It does not matter, right? So you can just choose whichever one you like better. Okay, and then find the x-intercept. Well, what we need to remember for an x-intercept is that's where y is equal to 0. Okay, and so we're going to plug in 0 for y on any of these equations. It's always going to give us the same thing. I might go with that first one that we had, y minus 2 is 1/4 of x minus 3. So we have y minus 2 equals 1/4 of x minus 3. And we're going to plug in y equals 0, and we're going to solve for x like using the techniques we learned in the last lesson. Okay, so I've got 0 minus 2 equals 1/4 of x minus 3. Okay. Now to get at that x, I'm going to have to deal with the parentheses kind of last, right? So I'm going to multiply both sides by 4 to get rid of that 1/4. Okay. And then I'm also going to erase that 0, right? Because we know that 0 minus 2 is going to be -2. Okay, so I'm going to say, all right, multiply both sides by 4 to get rid of that. And I'll have negative 8 equals x minus 3. And then I'm going to add 3 to both sides. So I'll have on one side x, and on the other side I'll have negative 8 plus 3 is going to be negative 5. Okay. Now if you tell me x equals negative 5 is the x-intercept, well, that kind of looks reasonable up here, right? It looks like it's going to be over here where x is negative. But I'll be happy with x equals negative 5. But I think that the best answer would be to give the coordinates of the point that represents the x-intercept. So I think that that would be where x is negative 5, and as we were saying, y is 0. Okay. And you know, I think that's going to be about enough for today. I think that's all of the information I needed to get to you. So at this point, you just need to practice. So, you know, get to it. Good luck with that. And thanks for watching.